Okay, let's look at practice problem 9. This is the last practice problem in your notes packet. Yay! In this problem, we're going to be practicing with limiting reactants, which is what was covered in this lesson. Let's start by reading the problem. The equation for the complete combustion of ethene, which is C2H4, is shown here in this reaction. If 4.3 grams of ethene is reacted with 8.9 grams of oxygen, do the following things. The first thing we need to do is identify the limiting reactant. Now, in order to figure out the limiting reactant, let's look at those steps we just wrote down. The first step we need to do is we need to have a balanced chemical equation. Well, if we look at this problem here, you see how there are already coefficients in front of these substances. This equation is already balanced. So we're ready for step 2. Step 2 says we're going to choose one of the products to find. Remember, the products are the substances found on the right side of the arrow. It doesn't matter which one you pick, just pick one. I'm going to go with CO2 just because it's the first one I see there. So this is my choice. This is the one I'm going to choose to find in this problem. If you were to do this problem and choose water, you would get ultimately the exact same answer. So it doesn't matter which way you go. So looking back at my steps, the next thing I need to do is a calculation. I need to calculate how much of that particular product, in this case the carbon dioxide, can be formed based on each reactant. Notice what we wrote off to the side here. Oh my gosh, this is not one, but two calculations. Because we have two substances involved here, we're given values for two different chemicals. We have to do two calculations. So over here in my problem, I'm just going to kind of label that so that I can keep track of what I'm doing. So I'm doing two calculations. I'm going to start with each of the numbers I was given in the problem. So here's one number. I was given 4.3 grams of the ethene. So I'll start with 4.3 grams of C2H4. The other value I was given in the problem was 8.9 grams of oxygen. So I'll scoot down a little bit here, leaving myself room to do work for each of these. And I have 8.9 grams of O2. So to review what I'm doing here for these two calculations, I'm finding how much of that particular product, in this case it was the CO2, the thing I chose, can be formed. So for each of these calculations, I'm starting with the value I was given for grams of ethene or grams of oxygen. What I'm trying to get to is grams of CO2. So I'm just writing that label over on the right so I can kind of see where I'm going. If you look on your mole map, you find that you're given grams of A, which would be the grams of the original reactants, and we're trying to find grams of B. So I'll go ahead and walk you through this first one. I hope you're feeling comfortable with these calculations by now, but if you're not, we'll review it one more time. If you want to fast forward through these calculations, if you can do them on your own, do them on your own and check your answers with me. So I started with grams of ethene, so I'm going to put the grams of ethene in the denominator. I need to change that into moles first. So in my first step, to get from grams to moles, I use the molar mass. 1 goes with the mole, and in the denominator, I need the molar mass of C2H4. Taking out my handy-dandy calculator, I add up 2 carbons and 4 hydrogens, and I get a molar mass of 28.05 grams. So at this point, my grams of ethene have canceled. I'm at moles of ethene, so this is like the moles of A box on that map. So I'm working my way across. I'm ready for mole ratio. I'm going from moles of A to moles of B. So in the numerator, the B I'm choosing is the CO2, the chemical, the product that I chose in this reaction. To fill in a mole ratio, remember you look at the coefficients. So CO2 has a coefficient of 2 in the balanced chemical equation, and C2H4 has a coefficient of 1. So filling those coefficients in, canceling out some moles, I'm at moles of CO2. As a side note, you could actually stop the problem at moles, but I'm going to go ahead and go all the way to grams. The reason for this is because often problems will ask you to find the grams as a next step, so this way I'm saving myself a step, and because many of us feel comfortable going the full 4 steps or 3 steps to get to grams. So right here I need a molar mass as well, so I'm filling in 44.01, which is the molar mass of CO2. So, canceling out my moles of CO2, let's take out a calculator and see what that equals. Plugging all this in, I solve and get 13 grams of CO2 as my answer for this problem. What I'm going to do for my second calculation is the same type of calculation, again going to grams of CO2. So notice I'm going to the same units that I ended with for the first one, but I'm going to do it starting with the other number they gave me, which in this case is the 8.9 grams of oxygen. Times in a line, go ahead and pause the video here and do this calculation on your own, going from grams of O2 to grams of CO2. Okay, so I did my second calculation. It's set up pretty much the same way as the first one. In the first one, we started with the ethane and turned it into CO2. In the second one, we started with the oxygen and turned it into CO2. Looking at these two calculations, what I'm going to do now is I'm going to compare the answers. Let's look back at our steps and see what that told us to do. We're now on step 4. It says whichever reactant produces less of that product is the limiting reactant. And remember, limiting reactant is often abbreviated LR. So we're looking for which substance runs out first. According to this calculation we just did, we found that from the ethene, the C2H4, you would be able to produce 13 grams of CO2. This is like saying that from the amount of meat you have, you can make 13 sandwiches. However, from the O2, from the oxygen, the amount we could make here was only 8.2 grams of CO2, or like from the bread, only 8.2 sandwiches, for example. If I'm trying to make sandwiches using the meat and the bread, I can only make sandwiches until I run out of something. In this case, I can only make CO2 until I run out of something. In this case, I'm looking for which one gives me the smaller amount. And of course, the smaller amount would be this 8.2 grams that I see here. So I might make myself a little note because that 8.2 is less than the 13 grams. What that means is that the limiting reactant is the reactant that gave me the smaller amount that ran out first. In this particular case, that would be the oxygen. The oxygen produced less of the desired product, the CO2, than the C2H4 did. That means that the oxygen will run out first. Just like in the sandwich analogy, we ran out of bread. Here we're running out of oxygen. Oxygen is called the limiting reactant. To label this clearly in your problem, what you would usually do is after your calculations, label that oxygen is the limiting reactant. Box that in, that's your answer. The reason being because it produced less CO2 than the ethene did. If oxygen is the limiting reactant, then what that means is the other substance, the C2H4, must be the excess reactant. Okay, excess means what's left over at the end. At this point, we have successfully completed what part A of this problem asked us to do, which was identify the limiting reactant. We're now ready to go on to part B of this problem. For part B of this problem, it asks us to do another calculation. Specifically, they want to know the grams of water that get produced in this reaction. There are a couple ways you can do this to get the correct answer. What I would recommend is let's look back at our steps and see what they say. Look at step 5 down here. What step 5 says is that if you're calculating any amounts, you want to start with your limiting reactant. So we're going to do stoichiometry calculations starting with the limiting reactant. So for part B of this problem, I'm going to make myself a little note here that I want to start with the limiting reactant. And this is pretty much always true. Once you know who's limiting, that's who's going to start off any stoichiometry calculations because it's the one that determines how much you get of the different substances. In this problem, we had 8.9 grams of oxygen as our limiting reactant. What I'm trying to get to is grams of water. So I'm going to put grams of H2O over here on the right. I'm going from grams of A to grams of B. I think you know how to do this calculation by now, so go ahead and pause the video, calculate this one on your own, and then check your answer with me. All right, did you get an answer of 3.3 grams of water? If so, congratulations, you are right. Notice here I changed my grams of oxygen into moles of oxygen by using the molar mass. Then I changed my moles of oxygen into moles of water by using a mole ratio made from the coefficients of the balanced equation. Then I changed my moles of water into grams of water by using the molar mass of my water, H2O, and I got an answer of 3.3 grams of H2O. I forgot to mention sig figs in part A, but let's look at them here. We're starting with two significant figures in our first number, so after all these calculations, we should have two significant figures at the end. This 3.3 grams of water is how much water should form in this reaction. To refresh your memory, this 8.2 grams of CO2, that smaller amount that we found up there, those two amounts are your theoretical yield. So this is saying theoretically how much carbon dioxide should we get and how much water should we get. So for each chemical involved here, what we have is the theoretical yield of how much we should be forming. All right, for the final part of this problem, we're going to calculate the mass of the excess reactant that is left at the end of the reaction, because we know that the excess reactant is the thing that doesn't get used up. Well, let's refresh our memories. Who is that here? Because they don't actually tell me a chemical. Looking back up, I had identified that oxygen was the limiting reactant, which means that the other substance, the C2H4, was the excess reactant. It was the one that we had more than enough of. It could have made 13 grams of CO2. It didn't get to make all that, so some is left over. So what I'm trying to find here is the mass of the C2H4. In order to figure out how much C2H4 is left, let's think about what happens in this reaction. Basically, you have some amount of ethene, C2H4, to start with. And then in the course of the reaction, you use some of it. Well, the amount that you use is going to be subtracted from the amount you start with. That will tell you how much you have left over. This is kind of a common sense thing. If you think about how much of something do you have at the beginning minus the amount you used, and that tells you how much you still have left at the end. So which of these numbers do I know? Well, back in the problem, they told me a starting value for the ethane. Specifically, I had 4.3 grams of the ethene to start with. In order to figure out how much I have left over, I need to subtract how much was used. In order to figure out how much was used, I have to do a calculation here to figure out how much was used. Since I'm doing a calculation, like in the last one, I'm going to start with the limiting reactant. So my limiting reactant was 8.9 grams of oxygen. What I want to know is, in order to react all of that oxygen, how many grams of C2H4, the excess reactant, did I need to use? So I'm going from the limiting reactant, the O2, to the excess reactant, the C2H4, to figure out how much got used. This is a grams to grams calculation. I think you can do this one on your own. So from this calculation, I can see that starting with my 8.9 grams of oxygen, my limiting reactant, I was able to make 2.6 grams of the ethene, C2H4. So from my limiting reactant, this is how much I used of the excess reactant in order to react with it. It's like saying, how many slices of meat do you need to go with 4 slices of bread, for example. So what I'm going to do with that number is I'm going to fill that in as the amount that was used. So in this experiment, I started with 4.3 grams of the ethene, the C2H4. I used 2.6 grams of that same ethene. So subtracting those two, I find that left over, I had 1.7 grams of ethene. So even once I had used up all of it that could react with the oxygen, that's how much I had left over. This part C of this problem is probably the most complicated part of the chapter for many students. The key idea is to remember that it's just a matter of saying how much did I start with minus how much did I use. There are a few other ways you could get the same answer. So if you have a different way of thinking through it logically and it gives you the same answer, that is fine. But I think this is the simplest way to understand in terms of your logic. So you made it through the practice problem. Now go try your practice on your own.